All right, example 11. Example 11, this curve has parametric equations. Look at this pair of parametric. Remember earlier I mentioned there are some equations that cannot be easily converted to the Cartesian form, Cartesian equation. And this is a classic example. I would like to say that it cannot be easily to Cartesian. Right? Right? Not so easy. Yeah, not so easy. Not like cannot, but it's not so easy. Anyhow, what the question asks us to sketch. I would like to point all of us to this range of t, the range of values that the parameter can take is given, unlike example 10, if you see earlier, which means that when we sketch the graph using GC, you must take note of it. So let's go straight to using the GC, don't waste time. So the steps is this: you enter your GC, set the range of values of t, label the endpoints, all right, and we're done. Let me explain. You go to y equal, I've entered this exactly, the equation. Slow down. If you need to pause the video, please go ahead and pause the video and then you play with your GC. Make sure you really play with your GC. Then you go to window. I pick window. The window settings is such that now you tell the GC that the T minimum is -2, your T maximum is 1. Yeah, T minimum is -2, T maximum is 1. Yep, because T ranges from -2 to 1. Then you go to graph. Now my graph looks a bit nicer. Maybe yours is not so nice. Okay, yours may look like this. Let me try and simulate what your graph looks like. Your graph may look like this. Now, in the event that your graph looks like this, then how do you then see a nicer graph? Because if you look at this very carefully, you don't know how this part of the graph looks like. Just now I mentioned how to use the zoom function. You can actually, in this case, a very good opportunity to use zoom box here. Zoom box. How? You go to one corner that you want to start, you press enter, and you draw a box. And you press enter again. You realize that very nicely done, you have this. Now, let's remember this shape. We go back to the question. Because there are fixed range, fixed endpoints here, that means t can only take -2 to 1. You realize that the graph actually gets chopped off here. There is some what we call endpoints. These are critical. Or you get chopped off here. These points are what we call endpoints. They are critical. You need to label them. Now the easiest way to label is this. See, that's why I say you label the endpoints. Alright? Now, let's draw the shape first. Okay, let's remember this shape. Let's draw the shape first. You get this. You realize there are endpoints. My curve not very nice. Excuse me, I'm drawing freehand. But what I want to emphasize is this is what we call the endpoints. You must label them. Then you ask me, hey, Mr. Wu, how do we know what are the coordinates of the endpoint? The clue goes here. Actually, you actually can use your GC. Alright? You do suspect, not always true, but do you suspect that actually the endpoints come from t equals to -2 and t equals to 1? So let's go to our GC. Alright? First thing you do, you go to the trace function. Okay, you press trace one time. What it does is you actually go left, right. But I suggest don't use left, right. Sorry, I won't even suggest. I say don't use left, right. To give the exact coordinates of the endpoints, what you do is since you suspect that the endpoint is when t equals to -2, you enter -2 here. You enter -2. Enter. T equals -2. Then it's proven t equals -2, -4, minus 4. X equals to minus 4, minus 4. So here we can label minus 4, minus 4. Alright? Then, what about this endpoint? You suspect x t equals to 1, we press 1. Then you will get nicely x equals to 5, y equals to 2. Very good. But we actually also need, if you look at the calculation or rather the solution printed for you here, you actually, for curves, you also need to label the intersect here. Alright? Here. And here. Where it cuts the x-axis. Now it's not difficult. If you actually look carefully at the equation here, when y equals to 0, you can actually solve this one. Then you realize that either t is minus 1 or t is 0. When t is 0, x is 0. When t is minus 1, t is minus 1, you substitute in, your x is minus 3. So therefore, this is negative 3, 0, 0, 0. Replay the video if you need to understand how it came about. Alright, so I'm going a little bit faster, but it's okay, you can always replay it. Alright, so recap again, you are given this parametric. Rule of thumb, do not convert to Cartesian. Go to GC, sketch it out. Go to window settings to check that it is from minus 2 to 1. Look at the graph, you zoom in, zoom out, zoom box, whatever, to get a very nice shape out. Alright, endpoints, you use the trace function. I hope that's clear. Alright, that's example 11.